Hello, wonderful students. I just finished making the notes for 6.1 and I was like, you know what, let's try and keep these class kick ones going. Maybe that defeats the purpose of class kick. I guess we'll find out. So anyway, here is our U6.1 or our class kick for 6.1 solutions. So in coffee, what is the solute? As you hopefully just learned in the other video, the solute is the thing that is getting dissolved. So in this case, the solute is simply going to be the coffee, whatever is being dissolved. And then, as we also learned, solvent is pretty much always going to be water. The solvent is going to be the water, which is doing the dissolving. Describe how to make a supersaturated solution. I specifically said in there, in order to create a supersaturated solution, you must always, you'd have to pour in enough of the solute, that it would reach the saturation point, but you always have to heat up the solution and then cool down. Simply heating it up is not effective. You always have to heat up a solution and then cool it down. To give one more quick recap, I would really encourage you to go back and watch the other video for the full explanation, but to make a supersaturated solution, let's say let's do this at room temperature, so about 25 degrees, and let's say we follow this sodium nitrate line. If I were to take at 25 degrees and we dumped in, let's say 110 grams of potassium nitrate. Well, at 25 degrees, potassium nitrate can only dissolve about 95 grams. So what we would have to do is, as we heat that up, you'd actually be able to watch the stuff fall out of the solution. So what that would look like is you would take, and I'm just going to kind of draw on top of this all right now, but if you took and you dumped in 110 grams, what's going to happen is 95 grams is going to dissolve, and the rest of it is going to sit at the bottom, which in this case would be about 15 grams. Well, as you heat that solution up to what looks to be about 45 grams, as you heated that solution up, you'd slowly be able to watch this stuff that would sit at the bottom. Picture if you dump too much sugar into your Kool-Aid, a bunch of sugar is going to come sit at the bottom. You would watch that dissolve, and as that happens, you would end up eventually at about 45 degrees. You would end up with the full 110 grams dissolved, but that would actually be a saturated solution at that point because it's all perfectly dissolved. You're right on that line because you have not done this cooling down step yet. So next what you would have to do is cool down the solution just any amount, and now since that 110 grams is still dissolved, even though it shouldn't be able to, now you have a supersaturated solution. You have brought that over the line. Because until you cooled that down, all it's doing is following the saturation point. It's following on this line, and then it cools down, and now you're supersaturated because you're above the line. So there's kind of another recap on what supersaturation is. Basically, you have more dissolved than should be possible because you've heated it up and then cooled it down, so you're kind of tricking the chemistry a little bit. Would it make more sense to make hot cocoa with warm milk or cold milk, and why? This goes back to kind of those last slides in our notes where it simply talks about increase in temperature, for solids at least, increases solubility. So it increases how much can be dissolved. And you can see that again if I pull this chart back up. As we look at this, for pretty much any solid, as you increase your temperature here on your x-axis, you're going to increase how much can be dissolved, as you can see on your y-axis. So hot cocoa is going to be a lot better, and that's also why I like hot tea. You can dissolve more sugar. Would the picture be an example of an unsaturated, saturated, or supersaturated solution? Since we look at this, you can actually really see in here, in this test tube, since you can see stuff at the bottom, this is almost identical to when I just drew out the example for a supersaturated solution. In terms of, I said, you're going to have some in there and then you're going to have some buildup at the bottom. That's what this is. the solution is maxed out. It has dissolved as much as possible, and so now you have all the extra stuff that your water or your solvent couldn't dissolve is just going to go sink to the bottom. So you have two different ways that you could actually dissolve that stuff. I would actually encourage you to take a minute and think, what are two ways that you would be able to dissolve that? Hopefully you paused the video. So you could either add more water or you could heat it up. So would the picture be an example of an unsaturated, saturated, or supersaturated solution? Sometimes students want to answer supersaturated. We didn't heat this up and then cool it. So this is not supersaturated. This is a saturated solution. Why? Because we have maxed out how much that water can dissolve. It is dissolved as much as it possibly can, and you have this buildup at the bottom, so it is saturated. That stuff is not dissolved in the water. All right, I hope this helps. If you have any other questions, please make sure to ask.